Sir, audible.
Very good morning to all of you, and it is very happiest moment for me that we have successfully completed 8 sessions, and now we are entering into ninth session. This is very great day for us, and today's expert, Dr. Dinesh Singh sir, is actually expert in the same field. He is working for many years in the same field. So today we have a session on security, privacy, and research challenges on IoT. The session will be lecture will be delivered by Dr. Dinesh Singh. Dr. Dinesh Singh is assistant professor in Department of Computer Science and Engineering at very prestigious institute of the country, Madan Mohan Malviya National Institute of Technology, Prayagraj, earlier known Allahabad. He did his BTech from Uttar Pradesh Technical University. Presently, it is Dr. APJ Abdul Kalam Technical University, Lucknow, Uttar Pradesh. He completed his MTech in Information Technology from IIT Roorkee and earned his PhD from MNIT Allahabad while working there. His teaching experience goes from 2006 to 2009, then from 2012 to till date at MNIT Allahabad. He is supervising 4 PhD students, out of which 3 are about to complete. As far as I could find from the website, if I am wrong, I will request to sir to please correct later. And he has also supervised a large number of MTech and BTech projects also. He has delivered many invited talks in different premier institutions at different FDP conferences, etc. And today he will deliver his talk on security research challenges in IoT. I welcome from the depth of my heart to Dr. Dinesh Singh sir. Welcome, sir.
Thank you, sir. Thank you. Thank you, sir. Sir, can we turn off the camera or we have to on camera?
Yes, sir. You just share your screen.
Yes, I just said.
Your
Okay.
video will be automatically muted.
Okay, okay. Thank you, sir. I just start to sharing the content and start the presentation for today's lecture. Okay. So, good morning, all of you. Hopefully, you find the contents, PPT. Hello. So, contents are shareable?
Yes, sir. Yes, sir. It is visible.
Okay,
Yes, sir.
okay. Thank you. Thank you. So, a very good morning to all the participants for this particular program. Today we start with some issues and challenges in IoT. In last few days, you all discuss many things basically related to the IoT architectures and some important application areas. Some machine learning algorithms related to IoT you study, some data analytics probably you studied or you studied in some other session. What the important part of this today lecture is what the issues and challenges, because if you are going to incorporate some research work either in MTech or some PhD work, so important thing your research is how you find the issues and challenges to start your research. That is very important. So many of you are planning or some doing research in this area. So this presentation definitely helps you to finding the important issues and the challenges related to this field. So we start the today's lecture on this topic. So we just go through a brief introduction of the IoT. So what IoT is, this is Internet of Things. So we all are uses the internet. So we know this is a kind of a network, but this IoT, that is an Internet of Things, basically many different objects, either the physical objects or some logical objects. So a network of such objects is basically an Internet of Things. So a very common terminology we use for this particular technology, IoT, that is anytime, anyone, and anything, right? So we use this technology at any time, for anything, or for anyone, right? So this is a kind of a network through this which we can connect all different types of objects available in our surrounding, or either the objects are physical objects, either the objects are the logical objects, right? Hello. Hello, UP Singh sir.
Yes, sir. Yes, sir. You are audible.
I'm sharing the content, but someone is controlling the presentation, I think, because so due to that the contents is goes off. I again share, but someone is attempting. So manage the permission, because I have no option to manage the.
No one is permitted except me do any administrative work, and today my computer malfunctioning. So fortunately I have joined this session. I have started this session with mobile. So
Okay, I again
please,
share the content because
to continue once my laptop is switched on. I will address the problem. I don't think anyone other can control.
Sir, content are not displaying. Content are not
definitely.
visible.
Sir, I
Yes,
request you to kindly restart.
yes, I just
Your
restart.
content.
Okay, sir, just
I'm
restart.
waiting for laptop to switch on.
Okay, sir, okay. Okay. So, are you getting?
डॉक्टर डीके साहब,
Sorry,
डॉक्टर डीके साहब,
Hello.
एक डॉक्टर डीके सिंह साहब,
Yes, sir. Yes, sir.
हाँ, ये ऐसा है, जितने लोग देख रहे हैं सब पर ये आ रहा है टेक।
Hello. Hello.
Sir, your screen is, your PPT is now visible, and due to malfunctioning of my system, if control by some with some technical issues, the control goes to everyone. I request everyone to please do not alter
यूपी
it.
सिंह साहब,
Yes. I request
यूपी
everyone
सिंह,
to do not do any disturbance. Sir, please. Respected speaker, sir, please continue.
Okay. Okay. So, as I told you, the basic definition of this Internet of Things, this is a kind of network of the different objects, either the physical objects, either the logical objects, or any particular concept. You can, if you embedded with some hardware resources, enable the communication with those resources. So that is, if you formulate such a network, so that is basically known as an Internet of Things. You can tell. Now, you see the communication scenario is changed very rapidly from the last few decades. So if you go 20 years back, so you can find basically the communication is basically a human to human with the help of some letters and some other. Then we goes to a some wired computing area where we have to some dedicated machines. Using those we can establish communication and do our task. And in next decade we move on the wireless computing era, and now we are in a stage of machine to machine communication where all the devices are enabled with some communication setup. So all devices are communicating in an intelligent manners with their own communication protocol and communication setup. So now the IoT is basically a machine to machine kind of the communication, where the one machine means a device which is monitored by means of sensors, because in IoT, you know, the sensors are very important component. The two means the kind of the network, because the devices are communicating, so they are using some networks. Sometimes they are using wired networks, sometimes they are using wireless networks. Mostly they are using wireless network in the backbone. Sometimes they are using some wired network. So that means of the two, it means, and the next machine means there is some kind of a control, right? How the machines control the some other machine, like a master kind of the terminology, master slave relationship. So some central server is there that can monitor all the connected devices to establish the communication and to exchange data. So from the human to machine and from machine to machine movement, so there are few things that should be addressed. That is how we capture the event and filtering of such event for the timely response. Because if we are moving to machine communication, so important thing how we capture the event, because lot of number of the events are happening. So there is a there is a very close coupled correlation among those events data. So how we filter that so that we can get timely response, that is very important for machine to machine communication. Computing delivers innovative solution, because we machines are embedded with some chips, so electronic chips. So we have to understand the computing delivers solution. At the same time, we have to understand the interconnected communication. So that's why we are saying that anytime, anywhere, anything connectivity. So we have to address the issues of channels. And another dimension that we have to address, that is an intelligent, because the devices are intelligent day by day. So how the devices capture the user behavior, how they incorporate business intelligence, how they incorporate the interaction with the users, these all things are very important for the IoT or some machine to machine communication enabled in your IoT network. So this is a data that you can observe very closely how IoT very close to our society, because the impact of the IoT is much more on our society, and it is increasing day by day, because the number of the devices that are connecting over a network is increasing day by day. So this is a basic fundamental how IoT will work. So this is a foundation of IoT, that is an RFID technology. So with this RFID technology, this IoT network identify and track the data of the things. With the help of the sensor, it collect and process the data. A smart tech that this is basically to involve in the network, enhance the power of the network, by developing processing capabilities to different parts of the network. And nanotech, you can say this make the smaller and smaller thing have the ability to connect and interact. So you can say there are four basic layers of the IoT functioning. So from the RFID to nanotech, you can say that this is a layered structure for IoT functioning. So what are the actors in your IoT? There are two important actors in your IoT. The first thing, that is your devices. Devices are basically constrained devices, because many constraints are defined over the devices, because device types and their characteristics are varying very much in your IoT network. So important constraint for the devices, that these devices should be of a low cost, low power devices. The communication, that they are able to communicate with the short distances. That's why we go to the WSN or RFID kind of the communication. They should have efficiently sense the environmental data. The perform limited data processing. The capability of computing on such devices is limited. Sometimes their devices have their high power, but because IoT is a kind of network that can connect any small kind of the things. So in that such device, the computing power is very limited. So to handle that communication, that is device constraint should be considered in an effective manner. Communication between devices and other entities relies on the radio wave, which is susceptible to many attacks, right? So communication, because now devices are communicating using your radio channel, radio waves. So a lot of attacks are also be possible, right? So we see some of the attacks. Now here you find the important constraint and their implication. One important constraint, that is a resource constraint, because devices that you consider in your network, so many constraints are defined. You see some constraint that is low cost, low power. So what the protocol you have to design for such resources, that protocol must be energy efficient, right? That can save the power of that device, right? Right. So this is a kind of a research issue that you can consider for your IoT network, that the devices should be energy efficient. The algorithm means the devices means there are kind of the algorithm that is running on the devices that should be an energy efficient. Operation unattended, because some operations are distributed in nature, so devices can capture, adversary can capture any device, right? Using those operational distribution, it is very frequent that devices can be captured by adversary. Not temper registered, that is a kind of a constraint. Adversary can, hello, you missing, sir?
No problem, sir. You are audible and your PPT is visible.
Yes, but someone is attempting to change the slide and some other permissions. So it is better to manage the permission on your side. You can check the manage, and where there is a presenting, in the mode of the presenter, you allow only the presenter mode, not for everyone. If you check the permission.
I am unable to understand the technical difficulty. Only I am allowed to do
Okay. I continue. If any problem is there, then I can told you. Okay. So lack of the not tempo resistant means because devices that are uh, not much more tempo resistant, because there are some small devices that are participating inside the communication network. So if we enable a lot of the security implication over those devices, so definitely they losses the performance of that device, right? But if we are not incorporating the security issues over those devices, then definitely there will be a chance to compromise the device data, right? So some constraint in IoT network is that we have not allowed the temper resistant. So if we don't go to allow the temper resistant, then there will be a definitely be a chance of the compromising the device data. So we have to design some algorithm in such a way that there is some balance of the trade-off between these two components. Lack of central control, right? So in general, because in general what is happening inside the network, that the devices are not always be a master slave kind of the thing. So every device have their own control to manage and participate inside the network. So if that is the scenario, then there is a cooperative data exchange is there. So if cooperative data exchange is there, so definitely there will be chance to modify the of the data. So we have to incorporate such constraint as well as the implication of those constraints in very alert mode. No pre-configured topology. In IoT network, the topology is very dynamic, right? So in that situation, devices do not know their neighbors in advance, because there is some mobility involved in the network. Many devices are mobile. So in that case, the topology of the network is very dynamic, right? So devices are not aware about their neighbors all the time. So we have to consider such constraints so that we can design an efficient IoT network. Now there are some issues why we go on IoT as our research challenge and research problem, because there is a dynamic control of industry and daily life. Now you can see IoT have a great influence on the industry as well as in our daily life, right? Every industry incorporating the IoT kind of network for their production, and we also see some daily life examples of IoT that can help to solve many of our daily life problems. Improve the resource utilization ratio. This is a very important point. Resource utilization. Resource utilization, because before the kind of the network, IoT kind of network, the resource utilization is not be such high level. Either the resources of the human resources, either the device as a resource. So definitely this IoT improve the resource utilization, right? And if the resource utilizations are improved, you can understand the throughput of the system is also be improved, right? So IoT improve the resource utilization, so the productivity of the industry as well as the productivity of the system is improved, throughput is improved. Integrating human society and physical system. So IoT is not only improving the resource utilization, it integrate the human society. Now you can see a lot of the social communication over the IoT network. So things are in the shareable mode. So somehow this IoT integrate our society. We think that this is not integrating, this is not integrating our human society, but this is wrong. This is somehow integrating our society, because we have some option to share the information as well as share the resources with some others of our society, with the help of such network. Flexible configuration, right? Because the devices or objects involved in the IoT network, so we are on the way to design the protocol application in such a way that is flexible to configure for every end user. That's why we use IoT in much of our daily life. This is also act as a technology integrator. Yes, this is a technology. From the technology point of view, if you understand the IoT, this is also be a technology integrator where you find numerous number of technologies. Those are integrated to formulate such a large IoT network, right? Universal internetworking. Around the world, you find many type of the network. If you look IoT, so this is kind of a network that universally interconnect all the different types of the devices. So you can find IoT is a kind of network that can integrate all the types of the devices available in every corner of the geography, so that the every device or every object is identifiable and it is enabled with the communication capabilities. Now, what are the requirements for IoT networks? So if we are going to design the IoT network, then firstly, the things that comes in our mind, what should be the requirement for IoT network? The first thing, the capacity to connect a large number of heterogeneous elements. Because in IoT network, you understand the devices are of the heterogeneous nature, are on the uniform communication setup. They are heterogeneous. So how we utilize the capacity of such devices so that they are connected, they provide the connection seamless. That is an important requirement, right? So high reliability, because the communication should be very reliable. That is a kind of a requirement because this is a kind of a network. So reliability is all time very important, because many of our daily life or some fundamental industrial applications are executing over the network, like your video processing, like your some other important application sharing. So reliability is very important. Real-time data transmission with minimum delays. That is a kind of the requirement, right? So how on the IoT network you ensure the real-time data transmission with minimum delays, right? Like uses this Microsoft Team as a platform, right? So how this provides a real-time data transmission without delay, right? So in kind of an IoT network where the platform is not uniform, that is heterogeneous platforms, heterogeneous elements. So over those heterogeneous elements, how you provide the real-time data transmission with reduced delay, minimum delay, that is a very important challenge requirement. Ability to protect all data flows, right? That is a security issues, right? Because number of the data flows are there among the different devices. So over those data flows, how you protect the data? How you protect the data? What kind of algorithms you consider for that? Because the algorithm that is using for your data protection, that have their different requirements and their solutions, right? So the algorithm you are designing for ensuring the data security is also be a kind of requirement. Ability to configure applications, that is a kind of requirement, means how we allow to configure our applications on such network devices, right? monitoring and traffic management at the device level. Sometimes there is a requirement to manage the traffic and to monitor that traffic also for analysis purpose, right? Sometimes this monitoring is violating our privacy concern, but sometimes we require this monitoring at the device level. So once the monitoring is allowed at the device level, so at the same time we have to manage the privacy or security concern, right? So we have to manage these two trade-off. Cost effectiveness for a large number of connected objects. So definitely cost be an important requirement. Whatever network you are formulated with the different objects, definitely there is an associated cost with that. So you always keeps in your mind whatever network you are designing with the help of this communication technology, that should be a cost effective. Now this is kind of issues that comes in our mind for against this IoT network. The important issues are availability, right? Large number of the devices are there. So how we ensure the availability of those devices, right? Sometimes there are many permission mode for those devices. If we need to access that device, but at the same time if permission mode is not be supported, so how we ensure that such condition would not be occur? If we need to access that resource either hardware or software resource, that resource should be available, right? So that the delays are minimum, right? So this availability, ensuring the availability of the hardware and software resources. Hardware resources may be your physical resource, right? Maybe your storage component, right? Maybe your some external device like your printer, like your other resources. In terms of the software resources, you can say some applications, some files, right? If your network demand, if your any device of the network demands some particular file, and if that file is not be available at that moment, so definitely some delays are involved, right? So such delay, to minimize such delays on your network, the availability of the hardware as well as the software component should be high, right? So one important dimension of your research may be how you ensure the availability of the resources in such network. At the same time, reliability is also be very important, right? Reliability means some devices, some hardware resources are involved in your system. How you ensure that there is no failure of such resources, because a lot of the computing involved over such resources, right? So not only the computing, in terms reliability in terms of the threads is also be, right, should be ensured, because many types of the attacks are possible, right? So your communication should be reliable against such attacks. So whatever network you are designing for particular application, because reliability requirement is different for the different application scenario, right? Some application need low reliability, some application demand a high reliability, right? So the reliability requirement varies, and this reliability requirement not only depends upon the application, this also very depends upon the network as well as the available hardware, right? So you have to ensure the reliability in all different component scenario. Mobility, in network devices are mobile, right? Many devices are mobile, some are stationary. So if the mobility is involved inside a network, so there are many challenges are there, right? So many challenges in terms of the connectivity of the devices, right? So once some mobility is there, so we have to consider the mobility issue. Sometimes the communication link failure is there due to the mobility. Sometimes the position of the devices is out beyond the network reachability, right? So all such issues should be considered once you design the IoT network. Working ability and performance, right? So services updated from time to time with good quality and low prices, right? So what kind of service application you are providing over this IoT network, so that should be updated at a regular time so that the performance of that application is never degraded, right? Data confidentiality. So lot amount of the data is exchanged over such IoT network, right? So sometimes the requirement of application is highly confidential. So in such scenario, how we ensure the confidentiality of that data to the end user, right? What kind of algorithm we incorporate to ensure such confidentiality? So that is a kind of an issue we need to address in such network. Management of network and resources, right? So inside a network, many intermediate components are there, right? So to manage all the intermediate components of the network and their performance is an important issue for discussion in this network. Scalability. Yes, this is a kind of a good issue in IoT network because large number of the devices are connected in IoT network, right? And you see in a diagram that the number of connectivity of the devices is increasing with a very rapid rate, right? So you can say this, your network should be highly scalable to add new devices, not only devices with the software as and application components, right? So how you design such a scalable network, because this is not an easy task, right? Because you know the heterogeneity of the devices. So scalability, lot of research work over the scalability of the IoT. How you ensure that your applications are performing seamlessly with allowing many number of devices in that can connect it at later stage, right? So this is very challenging. Interoperability. You understand this interoperability because interoperability may be in of many sense. Either interoperability may be from the device point of view, either it is from the network point of view, right? So whether it is device or network point of view, but issue should be there that the application should perform efficiently with such interoperable environment. Security and privacy. Security and privacy, because the data that we are communicating, transmitting over this network, we need to provide the security of that data, right? Not only the security, sometimes privacy of that data is highly desirable, right? So how we ensure the security and privacy of that data? So that is an important issue in IoT. Software defined network. This is a very important issue. Software defined network. So many of the network
Sir,
functionalities, yes,
can I interrupt for few seconds?
yes, yes, no issue, sir.
Actually, I just talked to Microsoft
Okay,
and they replied that while presenting PPT, everyone can take control. If you share
okay,
your screen, no one can take control.
okay, okay.
So I think you are sharing PPT, not sharing the screen. Therefore,
Yes, yes,
control goes to everyone.
okay,
Thank you, sir.
okay, sir. So software defined network are basically some softwares, those have a control of the many of the network requirements, right? Network requirement means many of the network devices are controlled with the help of the software layers, right? So this is very important in terms of an IoT, because over an IoT there is kind of a layer, and that layer is responsible to manage many of the network resources. So many of the research in this kind of network, with the help of this software defined technology. So now what kind of the challenges with this IoT? You see the many of the issues of an IoT. Now what are the challenges? So challenges in IoT in terms of the standardization, right? Because till now there is no common standard available worldwide for this IoT. Many of the players are working in this standardization of IoT, so that we can got a good protocol stack of the communication. But unfortunately, we are not successful in this. The standardization process in this is in on the way. So standardization in terms of the interoperability, standardization in terms of the heterogeneity of the sensors, in standardization in terms of the interfaces to the cloud server, because the most of the data that we collect with the help of the sensors in IoT network, that is stored on the cloud servers. So the standardization is required in all three dimensions, right? So research is going on this standardization of the IoT protocols. Now you see many of an application of an IoT, right? You discuss in last few of lectures, you see many of an application. Now today we discuss what are the research challenges behind these applications. So important of IoT application that you see: smart building and homes, smart grid, medical and healthcare, agriculture and building, public safety and environment monitoring. You see some smart mobility, industrial processing, smart transport, many of them application of IoT. Now we see what are the challenges behind such applications. So if you look the smart home, what this smart home concept is there, inside our home, many number of the devices are there. The objective is how you ensure the connectivity among such devices, and that connectivity should be an intelligent, right? So that is some automated kind of a connectivity. So to enable that, to enable such communication among the equipments or devices available inside our home, So many number of the sensors are deployed for this purpose, so that devices are really in an intelligent and automated manner they are communicating. So what is the challenge behind this? Requirement differ from environment to environment. Now, if you design a kind of network, so the requirement of that network differ from environment to environment. If we are living in a plane, the requirement is different because the room temperature that we need to manage with the network, that is somehow different than the room temperature we are managing inside our home at hill, right? So the requirement of such application, you cannot say that the home application, smart home application we are designing you against this IoT network is seamless, right? So the requirement is different. So how you can ensure the communication scenario using this IoT network that can provide better experience to the end user, that is an important challenge. Higher cost involved in installation of devices, right? Cost factor, right? Cost factor, because many number of the devices are incorporated, many sensors are deployed. So what kind of the sensors you are deploying, right? It should be according to the number of available, because the number of sensors are deployed. This is also be a kind of research, because many number of devices available inside your home, right? This number is varying, this number is varying, right? So according to the variation in this number, you have to define a function that can compute the exact requirement of the sensor that should be deployed in your home, right? So this number is depends on the many of the parameter. This is not only depends on the number of the devices installed or available inside your home. This depends on the infrastructure, means some spaces inside your home, some other parameters are also be there, right? So if you increase the number of the parameters, so definitely the cost varies, right? So this is a kind of the trade-off, right? You have to compute the optimum number of the devices that should be deployed so that the cost can be reduced. So that is a kind of the research challenges. How you compute that optimum number of the sensor that should be deployed that can satisfy the demand of your home automation, right? Knowledge required to reconfigure if disconnectivity occur, right? So any disconnectivity occur. So because there is a kind, right? So if there is a kind of a wireless network kind of thing, so disconnectivity is may possible because there is some environmental issues are there. So due to the environmental issues, some disconnectivity may be there. So if disconnectivity is there, how we can reconfigure, whether machines are reconfigure itself, or those machines need some human intervention, or some rebooting of the whole network. So these all affects the cost, right? If machines are self reconfiguring with a minimum time, so you can say the cost, some cost is involved in terms of the use, right? So that is reduced. But if you say that we have to reboot the whole network in case of the disconnectivity, so definitely large amount of the energy is required, large amount of energy in terms of your electricity is required, or some battery power is required. So definitely there is a cost, high cost involved if some disconnectivity occurs, right? So how you manage this disconnectivity challenge in terms of reconfiguring the deployed devices so that the cost is minimized. So variations in protocols. So this is a cost to society, right? So this is a huge cost in variation on the protocol. If you vary the protocols, so a lot of the cost is involved. Same way, there is one more technology that is very common for today's scenario, that is a smart grid, right? So a smart grid. So this is because electricity and their use is the backbone of our society and humankind. We all are heavily dependent upon the electricity for our different appliances. So a smart grid is basically a kind of technology that allows to integrated electricity generation, transmission, distribution, and consumption system, right? So if a smart grid technology is there, because this is an example of an IoT network, right? Because you see in this whole system, electricity generation, some other type of the devices and infrastructure is there for electricity generation, transmission, some other devices are involved, distribution, some other type of the devices involved, consumption, you see many of the different consumption devices are there. So every stage there is a huge variation on the characteristics of the devices involved in this system. So if this is a kind of IoT network, then there are many challenges to manage this IoT network. The first challenge from the protocol side, how you design such a protocol that providing the services to different locations, because electricity generation may be on some other location, transmission may be through some different stages, distribution is some other characteristics, consumption have some other characteristics, right? Lacks of memory, right? Memory spaces, because lot amount of the data is generated in this whole process. So if lot amount of the data is generated, how you store that data? Is it any data reduction algorithm should be there before processing the data, or data aggregation schemes should be there, right? How you filter the data so that the redundancy of the data should be resolved, so that your memory spaces are optimized, right? So many challenges in this whole system, right, in terms of the memory spaces, because you know memory is a very cost factor in any system, right? Memory spaces, because you have to pay a huge cost for that. So if your data have a filtered data, then definitely that cost is reduced. So you have to consider this challenge once you work on the smart grid kind of IoT network. Self-computation is time consuming, right? Self-computation, because this is kind of a huge network. This is kind of a huge network. The smart grid is not a small kind of application. This is a huge network, right? So self-computation, right? Self-computation due to some failures in the system, either hardware or some software failure. So how devices are self-computing, right? Self-computing in terms of failure or in terms of some regular computation, because due to the large amount of the data, if regular computation is there, so there is a time consuming. So how you design some lightweight algorithms for the computation at every end of the system, either it is at the electricity generation, either it is on the termination side, transmission side, either distribution side, or either the consumption side. No proper data acquisition framework available, right? So this is also be a challenge, how you acquire the data, So in this application, IoT application, you have many challenges. You can do your research on every dimension of a challenge and gives your contribution to the technology or society. Now you all familiar the application of IoT in medical and healthcare, right? Now there is an extensive use of this technology in healthcare, right? So you see most of the devices, medical devices are enabled with Wi-Fi system, right? And many of machine learning or machine to machine communication is allowed inside this network. That's why this kind of a network is also known as an internet of medical things, right? So what are the challenges in such network? The first and foremost challenge is inadequate knowledge to end user, because in medical domain, you know, the medical terminologies are very difficult to understand for the end user. So if end user is not much aware about such medical terminology, so how it can work on such medical devices, right? So that is an important challenge. Sensors are highly overpriced because a huge cost is involved with such medical devices, right? Even if the sensors is deployed in the medical devices are of high price, because the reason behind this, that the accuracy level of the data that we collect or expect from such devices should be very high. So the sensors that is deployed inside this medical devices should be very high precise, right? So to design such sensors, there is a high cost involved against that. So how we design such sensors that can satisfies our requirement in medical requirement in terms of the medical domain, so that of the sensors is not be so high. That is a challenge. Highly complex mechanism. Yes, medical mechanism is complex, right? System design is this medical of internet things system that is designed, that is complex system, right? So how you reduce the complexity of that system by incorporating some efficient algorithm in terms of the reducing the computation, that is the challenge. Requires time to time update according to the patient health, right? So patient health, you see, sometimes patients are very serious. If you are incorporating a network that monitors the patient's health, so regular updates are there. Regular updates are there. If you compare this system with some other kind of the system, so the updates are very frequent in medical domain, right? Sometimes the duration of the update is very small as compared to some hello as compared to some other system, right? Some other system, because the health of the patient is very crucial for certain time duration if he is very is in emergency, right? So due to the update, large amount of data is generated. So if data is generated, so regular computation is required again and again. So that computation involves some cost, right? So how you incorporate such updates so that the cost in computation is reduced, right? Timely update required, right? As I am saying, the timely updates are required. So that is a kind of the challenge. How we get the timely update from the devices. Now, if you look this application, that is an agriculture and breeding. So in agriculture, you see there is an extensive, again we have very extensive use of an IoT network where many of the agriculture devices are connected for the purpose of better production. So what the environmental parameters involved in this, that is a temperature, soil information and humidity, and this is measured in real time and sent to the information sent to the server for the analysis, right? So in this application, what the challenge is, how you place your sensor devices so that it can accurately measure the temperature, soil information, humidity information, right? So finding or searching the location where we need to place the sensor, that is an important challenge. Many algorithms are designed for this purpose that can efficiently measure the temperature and other environmental parameters so that they suggest a better production mechanism. Another challenge is lack of awareness among the farmers. Right? This is a social challenge, you can say, right? Because the farmers are the end user of this system, right? So if farmers are end users, they should have at least some knowledge about the system, right? So if they are not much of awareness about the IoT kind of the system, so they are not interested to use such system for their better production. So we have also tackled some social challenges to aware the farmers for their use of an IoT. That is a challenge. Need to be cautious while performing agriculture activities because agriculture activities are time-bound activities, depends upon the environmental factors. So once we allow our system to incorporate the computation, then we have to be cautious about that.
Mitra, क्या बोल रहे हैं?
Now, public safety and environment monitoring.
मैं कौन होता हूँ मैडम बोलने वाला?
Public safety and environment monitoring, right?
आप लोग बोलेंगे हम क्यों बोलेंगे? मत बोलिए.
Public safety and environment monitoring.
नहीं माथुर ने वो आपने लिस्ट दी, माथुर ने मेरे को भेज दी वो. आप
Hello.
खुद ना उसको ग्रुप में.
Hello.
मेरे को देने के लिए मंगा है.
Please unmute your mic. Please unmute your mic.
कि उसको क्या पड़ी हुई है पानी की?
Afra Bashir ji, please unmute your mic.
माथुर को. हाँ हमको पूछ रहे हैं. उसको क्या क्यूरियोसिटी है? आशपा सब पूछ रहे हैं.
Please participant please mute your mic.
Jayan Deshpande, please unmute your mic.
Okay, thank you. So in public safety and environment monitoring, many of the challenges. What the public safety environment monitoring is a kind of the process for making observation on weather condition, endangered species protection, water quality monitoring, and various other parameters that directly or indirectly affects our environment. So many of the environment things are there. So those should be managed by such IoT kind of the network. But in that monitoring, what the challenges? Requirement differ as per geographic location. So the requirements of Indian society is somehow different than some European societies, right? So in such differing requirement, how your IoT network design so that they can perform better, efficient. Sensors installed in open, right? Because for such system, mostly the deployed sensors are in open environment, right? So there is a lot of chance that sensors are damaged by many of reasons. So we have to consider that, because somehow that involved with the cost of that system. Difficult to manage anonymous data. So in this environmental monitoring, large amount of the data is generated, because you can say in general that in IoT application, large amount of the data is generated, right? So this is a very common challenge for all the IoT application, how you can manage the anonymous data, right? So in some application, we see some big data and some other kind of the solutions are there to manage this huge amount of the data. So this is always be a challenge for every kind of an IoT application. Variation in protocol, right? So protocols are differing as per the differing environmental conditions. So if protocols are differing, how you design a seamless protocol, that is a kind of the challenge. And lacks in terms of the memory spaces. So if large amount of the data is generated, so definitely you have to manage your memory spaces, because memory is of the limited capability. One more thing that you see in case of one more application that you see of IoT, that is a smart mobility. A smart mobility is kind of a methodology that allows seamless, efficient and flexible travel across various. Now, if you are a moving object, so how the moving object uses seamless connectivity, feel the seamless connectivity at all time, right? Like a very good example, a very good technology that is a vehicular ad hoc network. In vehicular ad hoc network, this is kind of an ad hoc network, temporary network that allows the communication among the vehicles, because vehicles are highly movable, right? So if vehicles are mobile, so sometime there is a kind of network that establishes the communication among such vehicles, and this communication is not be a your internet kind of a communication or GPS kind of network. This is a totally ad hoc network, right? Vehicles are communicating with each other using some DSRC protocol, right? So this is DSRC is basically a short range protocol. So vehicles are communicating to each other to exchange the data and some other traffic related information, right? So in this, not only the vehicle, some infrastructure components are also being involved. Hello. There is just a wait. There is some issue in the content sharing. I again share the content.
Sir, please now share your screen.
Yes.
Sir, I request to share your screen. Don't share PPT.
Okay, just I just share it. Then if some other issue, then I share it. So in such mobility scenario, there are some challenges in lots of investment required in bringing up the infrastructure, right? Because either we go for the vehicular ad hoc network or some other driver assistance system, we have to incorporate some infrastructure component, right? Some roadside infrastructure component or some built-in component on the vehicles, right? So in every such incorporation, investment is involved. So how you allow this, that is a kind of a challenge. Penetration rate means, because now you see a very important application that on every toll plaza you find some FASTag kind of application, right? So some FASTags are enforced to enabled on the vehicles so that the automatic toll collections is there. But you see that nowadays most of the vehicles are not enabled with the FASTag, right? So the penetration rate, how penetration rate means how we incorporate the changes as soon as possible, right? So if some application is there, how we accommodate those changes, what the rate of accommodation. It is 1 year every vehicle is enabled with the FASTag, or it is 2 years or 10 years, because in every 5 or 7 years the technology change. So if you go with a large penetration time, so definitely new technology comes and your system is crashed, right? That is outdated. So you again need to incorporate the next, the whole output you planning for from your system, that is not be achievable. So penetration rate should be high, but how you ensure that penetration rate, that is a kind of a challenge. Compatibility issues. Compatibility issues is always be there in every IoT kind of system, because devices are of heterogeneous nature. So either the smart mobility or some other application, compatibility is always be a challenge, right? So the scenario of the compatibility is change as per the application changes. If you go with the vehicular application, you have to establish the compatibility among the different vehicular objects. If you go with the some environment monitoring kind of application, your compatibility among some environment means, you can say either the weather monitoring system or some pressure monitoring system, that is among that, right? So the compatibility issues change as per the application domain is changed, but this is always be an open issue of research. High cost involved in the installation. Yes, definitely there is a high cost, because the vehicular components are of the high cost, right? Are of the high cost. So how you can tackle the changes? Because if you compare your vehicular scenario, you see one hardware engine for a vehicle is designed at a time, and that engine is that engine technology is used for many years, right? That used for many years, although there are slight changes in there, but the basic architecture of that technology is not be changing. So that is used for many years, because the design of the technology takes much uh, uh, cost, right? So that cost is very important. Industrial processing. So industrial processing, you see IoT kind of the network in the supply hub in industrial park application, right? So here what kind of the challenges you find in industrial processing, where you have to get the sensors outdated from time to time, right? So if sensors are outdated from very soon, then how you design such sensor that can be incorporated for long duration, or they can reused, so that the cost of their deployment should be reduced. There is a chances of the malfunctioning, because this is a kind of the challenges. If you reconfigure the device sensor devices, then there may be some chance of the malfunctioning again, because the computation pattern that adversary is known. If you reconfigure the same sensors and reuse that again, so there will be a large chance of the malfunctioning. Smart transportation, you see this application with in terms of the IoT. So traffic surveillance and management application, like many of the surveillance application nowadays you see all the vehicle challans are issued by by your tracking devices, right? So if some violation in the traffic rules, some automatic challans are issued. So that is a kind of the traffic surveillance, right? So this traffic surveillance Along with the safety, this is also be an issue. Intelligent parking management, smart traffic light, accident detection application, a lot of the applications in the smart transportation. But what the challenges with this smart transportation? Again, we interoperability challenge. You have to consider that. And vulnerable to hack. Most of the connection with object which are enabled through RFID, and these are vulnerable to hacks, right? Because a lot of the integrated resources are there, so always be vulnerable to attack. Development of the private public partnership, security and privacy. Yes, in a smart transportation or some smart mobility, there is always be a challenge of the security and privacy. How you ensures the private information of the drivers or the vehicle is not be disclosed, right? So that is a kind of the challenges. So now we see some of the challenges in IoT middleware. IoT middleware, because if you see the different layers of an IoT, the bottom layer is the sensing layer, and in the middle there is a processing and the network layer, and above layer is an application layer. So either the 4 or 5 layer model in IoT. So if you look the middleware, other middleware means either the computation or the network layer. So what kind of the challenges? So for the first challenges, you find that interoperability and the programming abstractions, right? So interoperability, right? Because at the bottom there, different types of the sensors are deployed on the devices, right? So the challenge to the middleware is that how you incorporate those interoperable issues. So in this interoperability, actually in terms of the three, either in terms of the network interoperability, either in terms of the syntax interoperability, either in terms of the semantic interoperability. So in terms of the network interoperability means the different protocols that the bottom layer is using. So how different APIs are designed so that they can incorporate the network protocols, so that the application layer is not feeling those, and that application finds a seamless connectivity among the devices, right? If you go with the syntax interoperability, so you know the different data structures are used to process the messages at the device level, right? So there is a syntax, because every different device uses the different message syntax, right? Different data types for their processing. So how the APIs accommodate those challenges so that seamless connectivity is there. Semantic interoperability in terms of the abstraction of the process data, right? So APIs are available that provide this interoperability in every dimension. Device discovery and management, right? So devices are at the bottom layer, so APIs are enabled. Those are searching for these devices, because whether they are available or not, if they are available, they are establishing the communication among those. So that communication establishing also involves some cost parameters, right? So the challenge with the middleware, how they efficiently discover such devices so that the cost involved in that discovery is minimized. Scalability, right? So if new devices are incorporated in your IoT network, so the middleware have a challenge to incorporate those, devices with the reduced cost. Means without changing much of the protocol syntax, right? Much of the protocol syntax, or restructured your IoT network, your API should be capable enough that should allow this scalability in your IoT network. Big data and analytics, that is kind of a challenge. Big data and analytics, because a lot amount of the data is produced at the bottom layer devices, right? So how such protocol at the middle layer is there that can incorporate such big data, and their analysis. Security and privacy, right? So the middle layer, because on the middle layer some network and processing layer is there. So how that network and processing layers incorporate the security and privacy issues. Cloud services, because this middle layer is interacting with the application layer, where application means because lot amount of the data is generated, right? So in general, in IoT network, this data is stored on the cloud. So you see many of the different clouds are available, right? Some fog computing, right? Because fog computing, you know, this is a very recent technology is there, because lot amount of the data, the computation involved in that data is the cost in computing behind such large amount of data is very high, right? So fog computing is kind of a technology that enabled the efficient computation for such large amount of the data, right? So middleware layers are also manage the protocol syntax with the cloud services. Context detection is what? The devices are of the different characteristic in the IoT network. Now whatever the data produced from every device, now if data is available at the central server, so at the central server, huge amount of the data, among that huge amount of the data, how they identify whatever data is relevant for particular context, right? So some efficient algorithm at the middle layer should be there that should identify whatever the context of the data for that particular application, right? Because some are relevant data for that context, some are irrelevant data for that context, because devices are not only producing only the relevant content, they are some redundant contents they are also producing. So extracting that data at the central server that is useful for your context only, that is also be a very big challenge for the IoT middleware. Confidentiality of information. Now if information is available, data is available at the central server, how you ensure the confidentiality, right? So that is a very big challenge in this. Now if you look the security and privacy concern, so security is basically related to the protection against unauthorized access, right? So there are two terms, that is an authentication and authorization. So there is a slight difference in authentication and authorization. Sometimes some user is authentic, means is genuine user of the system, but he is not be authorized to use the resources of that system. So you say that is not authorized to access those resources, right? So security is basically the protection against unauthorized access. If you are not authorized, so you are don't allowed to use that, right? So right, where the privacy is basically ability to protect the sensitive information about personally identifiable information, your personal information, right? So your personal information is protected in such a way that some intruder cannot use that information. So if you ensure the privacy and security challenges, right? Because privacy and security is very concerned in the IoT network, because most of the IoT networks are designed for our day-to-day life or some industrial application. So either in our day-to-day life or in some industrial application, every time we need to ensure the security of that data as well as the privacy of that data. Some applications do not require the privacy, but some applications are strictly required the privacy also, right? So in security, you know about the basic security mechanism, that is authentication, integrity, confidentiality, based on an application and many other security requirements. This is depends upon the kind of an application, what the requirement of the application. Here we have some universal authentication, some identity management, authorized access to data, right? Availability of a data, right? This is a big challenge in near future. Availability of the data. What? Because huge amount of the data is there. what the demand of at an instant, whether that demand is available or not. Because among the huge data, if you explore or if you mine the required one, that takes time. So ensuring the availability of a data, that is a very great challenge. Lightweight security protocol for constrained environment. Yes, lightweight security protocol. You know, the security is to securing, because securing data is one issue, but at the same time, you whatever algorithm you have to design for your security, that should be lightweight. That should be according to your system. According to your system means that is compatible with your system. If you impose 2 or 3 security algorithm, then definitely your data is secured. But can your system bear that security algorithm? Bearing of the security algorithm means what the response time you retrieve from your system. Because if you incorporating 2 or 3 security algorithm to protect your data, that's good. That's good. But the cost involved in that, cost involved in terms of your response time, that is very high, or you can say very large response time is there. So if it's a very large response time, then definitely the interactivity with your application is decreases, right? So definitely that's a problem with you. So security is not the just providing the security of your data, but providing the security of data under certain constrained environment, constraint of your application, whether your system, your applications support those security requirements or not, security algorithms or not. Privacy preserving services, right? So same way you have some privacy issues if your system is server-side or not. Trust and ownership issues. At the same time, you have to ensure the trust issues, because some data is exchanged among the network, right? So sometimes you have to requirement of the trust over the communicating devices, right? So here you see a small example scenario where you have a prover and verifier. So in this case, what two entities, prover and verifier. So prover says, yes, I am Bob, and verifier says, verifier send a message to a prover, who are you? Prover said, I am Bob. So now here there are some issues of an authentication. How verifier knows that the whatever message he is receiving, that I am Bob. So prover is exactly a Bob. How verifier knows that? So some meaning of an authentication, meaning of an integrity issues is there. Integrity in terms of the content modification. So there are two types of an integrity. One is message integrity, and another one is some user integrity. So if you see here in this example scenario, what you find, some verifier sends a challenge to the prover, and prover sends a response. In the response message, prover sends the original challenge message and encrypt that challenge message with some shared key, right? So some key is shared among the prover and verifier, so that verifier decrypt this message and it find the original challenge it is sending to the prover. So if verifier receive the original challenge, so he is ensured that other entity is there, that is whom I need to communicate. Now if verifier receive the response, he can further create one more message, and inside that message he put it the confirmation of the second message, and they encrypted with this message with the same key that is shared between prover and verifier. So if prover receive this message, he knows that I am communicating with the right verifier. So in this communication scenario, if you look, both prover and verifier ensures the authentication, right? And one more thing, integrity of the message is also being ensured, because the message is exchanged among the among the two entities is encrypted by the shared key. So if this is encrypted by the shared key, so and this shared key is because there are two different encryption mechanisms. One is a private key encryption and the other one is a public key. So here both sender and receiver uses a private key, right? Private key or symmetric encryption. So in symmetric encryption, only sender and receiver knows this key. So integrity of this message is also ensured. So depends upon the requirement. If you need a privacy preserved data, then you have to avoiding link or traces. If authentication preserved data is there, avoiding impersonation. If integrity preserved data, then we have to avoid data alteration. Confidentiality preserved data, then we have to avoiding unauthorized access to the data, right? So if your privacy is the goal, right? So it depends upon an application, whether the application demand privacy or not, whether application demand privacy along with the authentication, then you have to incorporate those mechanism, security mechanism, right? So this is not be, I am already told you, this is not be the journal you have imposing lot of the security algorithms to protect your data, because there is a cost associated with that. So research is not with that you have to design some algorithm that protect your data, but no, the thing is how you design your efficient algorithm, because efficient algorithm that have reduced computation cost, that have reduced energy requirement in terms of your IoT network, that is very required one, right? So if your privacy is required, so in this case there is a proven and verifier, sender and receiver, you can say. So a shared key is there, both of them share a single shared key. And one more thing that is assumed in this scenario, that prover knows the ID of the verifier and verifier knows the ID of the prover. So if these things are shared in any way before the communication establishment, then what the scenario is to ensure the privacy. If prover sends a challenge message to the verifier, now verifier creates a response message. What the response message is, whatever the inside this response message, whatever the challenge sent by the prover, and one response is created by the verifier. So challenge along with the response, along with the ID of the verifier, because ID of the verifier, right? And along with the ID of the prover, because verifier knows the ID of the prover, and this message is encrypted by the secret key. Now, if this secret key is known only among the prover and receiver, so if prover receive this new message, CR message, so it knows that he knows this key, so it can decrypt this one. So he knows that this ID of P, after decryption, it retrieve this ID of P, ID of V, T and R. So if this prover again send a message in response of this, now this message, if it received by the verifier, it can further verify and then it can ensure that privacy is preserved, right? So in this communication scenario, what thing is assumed that both of the sender and receiver exchange the secret key. So there are many of the algorithms are there that can use to share the private key distribution. So this is a public key method to share the private key, because how the keys are shared inside the network, right? Inside the secured IoT network, right? So there is a requirement to exchange the keys. So this is a good method, efficient method to exchange the secret key using the public key encryption method. So here you see that both A and B are sender and receiver parties. So there is a third party, that is a third certificate authority party. So sender can send that public certificate, public key. So certificate authority generates a certificate to the CA. Inside the certificate, you see ID of user A and the public key of A and some timestamp, and this is encrypted by the this is a private authority. So if you see this way, CA and CB both receive this certificate. So if after the exchanging of this certificate, everyone get their public keys, private keys, right? Same way, this is another method for the key exchange. So we skip this method. These are the basic method to key exchange. Now, IoT scenario, there are number of the IoT applications. So it depends upon what the security requirement of your IoT application. So like your home appliances, transport, e-governance, social networking, defense, where our privacy is concerned, right? Privacy is concerned. If we talk about some defense application, definitely privacy is important concern, right? So to ensure the privacy, we have to see the previous protocol. So in this previous protocol, we see some challenge and responses. Now prover, if it receives the challenge, if it receives the response of the challenge, it can further allow the computation of that, and it matches the computation. If both computations are equivalent, then it ensures that whatever he received, that is as same one, right? So you see in this mechanism that both prover and verifier ensures the authenticity as well as the privacy. So it depends upon an application. Accordingly, we ensure the security algorithm. In such application like transport, e-governance, education, where authentication, integrity, privacy both are required. So if all three are required, then we have to slightly change in this, our protocol, right? So what the mean here is how we understand the requirement of our application. Accordingly, we have to select our security algorithm. So what the future of our IoT is, we have to consider the sizes, because the network sizes increases day by day. So we have to consider those sizes and design our algorithms so that they can effectively perform in such domain. Space consideration, right? Because if we deployed our IoT network, then definitely there is some space consideration is there. So controversies is also be a issue, because some other competing technologies are available. So how we consider those controversy issues, privacy, autonomy, and control, because this is very required, right? So all type, so what? Hello. So reality of IoT is not far around the corner. Yes, because in recent time as well as in future, we hope that.
Jayantesh Pandeyji, why you unmute your mic after few minutes? After every few minutes, you just unmute your mic and create disturbance. Please mute your mic.
Okay, sir.
Jayantesh Pandeyji.
Okay, sir.
So IoT is a very good kind of a technology that is becomes a reality in near future, and with good performance we see, and we hope in all our day-to-day aspect we use this IoT in some effective manner. Internet along with high-speed mobility communication. Yes, the communication scenario is changing. Now we are using the 4G network. In the recent future, we are going to upgrade on the 5G network kind of thing, right? So in future, we hope that we find a good communication infrastructure, so that the what we planning to communicate with this with the IoT devices, that is becomes good reality. Manufacturer service provider need to agree on a set of solution based on the functional and financial goal. Yes, because now the standardization is a very important issue with the IoT network. But we hope that in recent future that all the manufacturers are agreed on the IoT standards, so they design the their product according to that, and that satisfies the financial demand of the manufacturer, right? So we have to design, and from the security corner, we are interested to design the lightweight cryptographic algorithm. We have to incorporate the denial of service and some other issues. Thank you. These are some references. Okay. So
Very nice presentation, sir.
okay, sir. Thank you, sir.
Could we get the PPT of this slide?
No issue, sir. I just give.
Please hand it over to UP Singh, sir. So we will get all the participants.
Yes, sir. Yes, sir.
Yes, sir. Thank you, sir.
So thank you so
for
much.
your yes for your nice presentation. And audience, please, if you have any query, then you may unmute and ask the question directly.
There is
One
a
by one,
query.
please.
There is a query in chat box. Harish sir, please can you read out that?
Yes, I am trying to see. In the meantime, if any other person is willing to ask from audience. Yes, sir, it is from.
Yes.
Uh, Sir, the question is, with an introduction to 5G technology, don't you think that the security and privacy challenges of IoT device will be?
Yes, yes. Actually, the 5G development is under process. So, if some technology is under process, so we cannot predict what kind of the requirement would be there. But we hopefully we plan that such issues would not be there unless and until
Okay.
some technology not comes into picture. We cannot say much of that. Because security and privacy has always be a challenge nowadays for every kind of the protocol, right? We
Okay, sir.
hopefully
Hope he has been answered. She has been answered. Now, any other question from audience, please? I think there are no questions at all. And finally, thank you, sir, for such informative lecture. A lot of matter has been concluded in this.
thank you, sir. Thank you.
Yes, sir. Now, UP Singh, sir, will introduce our next speaker. And
Before
then we will
introducing
start.
the next one, I again request to Dr. Dinesh Singh sir that as our one of the participant Jain Deshpande ji requested for PPT. So
Okay,
I would
so
like to
definitely, sir,
request,
definitely. I suggest
if
mail you,
possible,
sir.
please send me in PDF or
Yes.
any other
Okay.
available form so that
Okay.
I can
Okay.
distribute it.
Okay.
Thank you, sir, very much.
Thank you.
Thank you, UP Singh sir.
UP, sir, you may please continue.
Uh, Respected Anil Malviya sir, are you with us? Are you with us?
Can we put over mic?
Anil Malviya sir, are you hearing us?
Yes. Am I audible to you?
Yes, sir, audible